Hi, okay, yep, thank you very much. A little bit of feedback there. Greetings to you all, thanks very much for coming along to our game audio presentation at Assembly 06. It's a great event. This is the first time I've been to Assembly. I'm really enjoying myself. In fact, it's the first time I've been to Finland. I'm going to tell you a little bit about myself first. Okay, that's gone off the slide, that's interesting. I work in the Developer Relations Group at Creative Labs Europe. We're based out of London in the UK. What do? We manage creatives' relationships with game developers and with game publishers across Europe. And our objective is to drive the adoption of advanced audio technology in PC game titles. So the idea is that if games sound great, and games sound great on our sound cards as well, and particularly if they support special features on Sound Blaster sound cards, then more people are likely to want to buy the games, buy our hardware, and enjoy the games on our hardware. Okay, I'm going to just very quickly switch applications because that wasn't really working. I apologize for this. The PowerPoint viewer is not playing as it should. There we go. Okay. We do this, we achieve our aims by going to game studios, by talking to them, by giving them samples of our sound cards, of course, and telling developers how best to code so that they can support our sound cards. And we also are responsible for creative developer tools. So you may already have heard about things like OpenAL, EAX, and Isact. Our group writes those tools, maintains those tools. I'll talk a little bit more about them later on. Okay. Personally, I specialize in working with developers in the UK and also the Nordic region because I love coming out here. In fact, as part of my visit here, I'm visiting some local development studios as well. In case you were wondering, I tell you what, I know what the problem is. Do you know if this supports 1280 by 1024? Large resolution? No? Okay. Yeah. Okay, don't worry. The slides might look a bit funny, but I'll tell you everything I'm going to say anyway. So in case you're wondering, my favorite games are, for multiplayer, I love Battlefield 2. I play a lot of Unreal Tournament 2004. And if you look out for me on the servers, my tag is Chief Wiggum. For single-player games, I'm enjoying Prey at the moment on PC. That's a stunning title. It's a bit funny. Sometimes you end up spending a lot of time going upside down, which makes me feel a bit nauseous. But it's got great audio. The thing with Prey is it's got fantastic audio. So if you want a recommendation for a game with state-of-the-art audio, that would be my recommendation. Outside of gaming, currently I have a project to build a Windows Media Center PC, which is a lot of fun. But anyway, let's move on, and I'm going to talk about the agenda. Before I do this, we have a list. My colleague Yuri at the back here has a list. If you fill in your email address, a current working email address on that list, we have some interesting giveaways for you. So first of all, we have, I think for everybody who's come along, EA have kindly given us download code for Battlefield 2142 beta. So you can be beta testers for that game. It's going to be a fantastic game. We're also giving away, we'll have a little prize draw, and we have an Xbox sound card, we have a gaming mouse, we have some headphones, some headsets as well. So please fill in your email address. I don't think we're going to send you any spam or anything, but we should be able to give you some nice prizes for some of the people. We'll send you an email if you've won that stuff, and we'll send everybody that download code for Battlefield. So, the agenda for today. When I was putting together this little talk, I've been told that the people that come to Assembly are absolutely certainly the kind of people who like writing their own stuff, doing their own applications, their own programming. So I decided that it would make a lot of sense to focus on audio tools, audio APIs, and techniques that are actually available to you, that you can download and get hold of yourselves. I'm going to talk a little bit about Creative, just give you some details about our company. I'm going to then start talking about basic 3D positional audio, how we achieve 3D audio on our products and on other audio renderers. I'm going to talk about what we call environmental audio, so that's some extra enhancements that make 3D audio more realistic. We're going to then focus on some important APIs and tools that are out there. Maybe tell you about the choices that are available to you and the features that they support. And I'm going to spend a little bit of time at the end talking about the future, what's next for audio, what's next for creative, what our focus is in the future. And we're going to leave a little bit of time for questions. But we're going to start talking about creative. very briefly. So some background. Creative born or founded, in fact, in the early 80s by a chap in Singapore called Mr. Sim Wong Hu. He's actually still the company chairman now, so he's doing very, very well for us. He tinkered with various different PC peripherals at the start of things, but the product, of course, that you all know about that really took off for us was the Sound Blaster audio card. So Sound Blaster has now been through a few generations of development. And each new Sound Blaster has been powered by a new chipset that's actually designed in-house by Creative, so we don't outsource that stuff. We design all our own audio chipsets. We have a tech center in California. We've always tried to cater for people who want to use their sound card for entertainment, for listening to music, watching movies. For people who want to make music, use sequencing, Cubase, eMagic, stuff like that. But gaming has always been a core focus for us at Creative. Having said all that, our sound card products now share kind of equal importance with our portable audio products. So you may remember things like the Zen Jukebox there. Now we have the Zen Vision. Those products are quite successful. They're doing well for us, but the X-Fi sound card is going to continue to be a core product, and game audio is going to continue to be a key focus for us, I think. We're going to continue developing the 20K chipset, which is the code name we have for the chipset in X-Fi. And we're also looking at taking some of the X-Fi technologies, things like intelligent upmix, 3D audio, sound enhancement algorithms, and we're going to start to put those into other products in the future, maybe cheaper sound cards, maybe other product categories. Okay, now 3D positional audio. We'll talk about some game audio basics. I don't know how old many of you guys are, probably a little bit younger than me, but you probably still know about the kind of dark ages of game audio, if you like. So things like Pong, Space Invaders, Commodore Amiga, 8-bit samples, and PCs that just go beep, FM synthesis, Sound Blaster 16. This stuff's all a lot of fun, and people agree that limited hardware limitations can actually breed creativity. If you have limited hardware to do stuff on, then it can make you very, very creative. But I think this old stuff is kind of irrelevant today. For me personally, I joined the game industry in 1998, and for me that's roughly when modern game audio started. So in 1998, Microsoft were evangelizing something called the DirectX SDK that I'm sure a lot of people here have heard about. So DirectX was Microsoft's attempt to unify this crazy world of PC hardware and all the different APIs, proprietary APIs that existed at the time to program all the different bits of hardware, and to bring those all under one API in the Windows platform. And in 1998, DirectX version 5 was released. And DirectX 5 included a component called Direct Sound 3D. So this is an API that gives programmers the ability to play back multiple audio samples simultaneously. Also to position these sound sources in space around what's called a listener, which is basically the 3D audio equivalent of the camera, and to move this stuff all around in real time. But the great thing about Direct Sound 3D in DirectX 5 for Creative Labs and for other PC audio manufacturers was that this is the first time that we were able to get hold of that information and hardware accelerate 3D audio. So that was really an exciting time for us. Today, pretty much, I would say pretty much every game out there uses 3D audio in some way. So this basic methodology that I described to you, this idea of sampled sound, sound sources, listener, 3D audio, is pretty much at the heart of most game audio engines. So we're going to look at it in a little bit of depth, how we actually achieve this kind of 3D, these 3D effects. And I want to talk about a little bit of technical stuff. I want to talk about some of the processes, or some of the algorithms that we use along the processing pipeline to get 3D audio in a 3D audio renderer. So here's a list of them. Okay, typically when you're developing a game, when you're creating the sound set for the game, there's a load of different sound samples, and they may well be recorded at different frequencies. So there might be 48, 44 kilohertz, high quality samples, maybe some low quality samples, 22 kilohertz. When a sound is played back, the first thing that has to happen is the audio renderer needs all these samples to be in the same sample rate. They've all got to be in 48, or they've all got to be in 44. So we need to do what's called sample rate conversion. Sample rate conversion itself is not inherently a particularly difficult problem to solve. But if you want to implement a sample rate conversion algorithm, that doesn't introduce artifacts and noise, that doesn't degrade the sound quality, that's quite a difficult trick, particularly if you don't want to burn a whole load of CPU usage. So alongside the digital to analog converters that are at the other end of the audio process, sample rate conversion is an area where you can win or lose the battle for audio quality. That's very, very important. Okay, when you're doing sample rate conversion, because you're fiddling around with sound frequencies, you can also at this stage take care of any pitch changing effects. So we all know if you have a racing game, they record a sample of an engine and they pitch it higher or lower depending on the revs or the speed of the car. So that stage also happens with the sample rate conversion. You need to provide gain control for volume so that the programmers and the audio designers can balance the level of the audio. And this is also used by the 3D algorithm to make sounds. If a sound's further away, it's going to be quieter, so we use the gain there. The next thing that we want to do is to deal with positioning the sound. If we might have a 5.1 system, we might have a stereo system, we need to give this 3D effect. I'm going to talk about that in more detail in a second. And then finally, we need to make a 3D mix where we mix all the sounds together. But let's focus on this idea of 3D virtualization. The term virtualization actually refers to making what you might call actually fake 3D sound for stereo or headphones. So if we have 5.1, it's reasonably easy, not trivial, but it's reasonably easy to build a multi-speaker panning algorithm that takes the position of the sound and then it figures out how much of the signal to send to which speaker. So if there's a sound behind me, I want to send it to the speaker behind me. That seems to make it's like common sense how that would work. Trying to squeeze 3D sound out of two speakers, or out of headphones, is a little bit more challenging, as you might imagine. If you only have two speakers, there's nothing behind you. How do you get this impression that sound's behind you? So you may have heard of the acronym HRTF, which stands for Head-Related Transfer Function. I'm going to explain how HRTF works. Okay, we have a picture here of a funny little head. This is actually a model that's designed to be physically similar to the typical human head. So we place some high-quality microphones inside these ears. They're kind of lifelike ears. And we generate what's called a binaural recording. So a researcher is going to make a recording of sounds placed at different locations around this head. And they want to do that in what's called an anechoic environment. So that's a room that doesn't have any acoustic effects. There's no reflection. There's no echo or reverb in that room. So we get these nice, clean recordings. And then we can analyze these recordings, and we can work out perceptual differences between our original sound and our recording taken from this different location. And we can then, when we've worked out these differences, then we can work out algorithms that actually use signal processing to modify sounds, and we mimic the 3D cues that we've extracted from these recordings. So I'll explain the kind of things that I mean here. So there's three main phenomena that we can reproduce for convincing 3D. And we've got a little diagram that shows here. We've got a listener, he's got a nice haircut, and we've got a sound source. It's a little bit to his left, a little bit behind him, or her. If we have two ears, we have two speakers, then we have two paths that the sound makes to get to those ears, or to get to those speakers, essentially. So the left path I've shown in red here, and the right path is in blue. So there's two things that you can notice, or probably a few things that you can notice about those sound paths. The left path is shorter than the right, because the sound is nearer to the left ear than it is to the right. And that's going to have some implications. That means that we all know about the speed of sound. Sound waves travel at a finite speed of 330 meters per second, or whatever it is. So that means that the sound is going to reach the left ear very, very fractionally before it reaches the right ear. So we call that phenomenon interaural time difference. There's a little time delay between the left and the right. Quite clearly, there's another thing. It's going to be a bit louder on my left than it is on my right. So we call that interaural level difference. And the third thing that's really, really important is that if the sound's coming maybe from behind me, it's going to be slightly blocked by, firstly, my head, the back of my head, and also these things, these are actually called the pinnae, but the bits of your ear that stick out of your head. So this is going to cause the sound to be kind of muffled. It's going to be dampened. It's going to have some special characteristics that you learn from when you're a child. You learn that when a sound is blocked, when it has this filtering applied to it, it's probably because it's behind you. So your brain works this out automatically. And we can recreate these effects using digital signal processing. So when we apply all these things to on a two-speaker delivery system, we can make a sound like it's actually coming from behind you. This kind of explains also why 3D audio on two speakers or on headphones, it works really, really well for many people. There's some people that go, I just don't get it. It just doesn't work for me. Well, clearly, it's kind of important that your head is quite similar to the shape of the head that is used to gather these recordings. At Creative, we have access to some research from a number of different companies, a number of different studies that have been done into doing binaural recording. So we've tried to optimize our algorithms so that they sound pretty good for everybody. But there's inevitably some people that say, well, it just doesn't work for me. So that's maybe the reason. If that's you, that could be a contributing factor. So now let's put all this stuff into context. Let's look at a flow diagram of how the audio signal flows in a typical audio renderer. I'm not actually intending to show you exactly how the X-Fi audio card works or anything like that. This is just to give you a flavor for the way that you would put together a 3D sound renderer. So we play our sample data here at the beginning. The sample rate conversion process that I told you about, where we convert the sample to a standard rate and a high quality rate, and we do any pitch effects. There's the gain. Then we do our virtualization, so our 3D speaker panning or our two-speaker fake 3D. And then we feed it into the 3D mix. But don't forget that in your games, you've got a whole bunch of sounds going on. So Creative sound cards, an X-Fi sound card can do 128 voices at a time. Different sound solutions, software solutions can do different number of voices. So there's going to be a whole bunch of different sounds. All of them are going to have this processing going on. So that's basic 3D audio. Kind of simple. Now I'm going to talk about environmental audio. So it's a bit of a buzzword. Maybe some of you understand what this is, some of you don't. It's a term that we give to enhancements that make 3D audio more realistic by modeling acoustic phenomena that occur in the real world when sound waves interact with the physical world. So if you like that the basic 3D system that I described just now, is a bit like the sound that you'd hear just in this anechoic chamber with no echo, no reverb. The key acoustic phenomena that we're all familiar with is reverberation. So reverb occurs when sound waves bounce off walls, ceiling, floor, things in the room. So we all know what reverb sounds like. It's this nice kind of this echoing wash of extra sound that's generated. The interesting thing about reverb, every room has a different reverb. Every room sounds different. So you might have a room that's a big room, it has a long, loud reverb like out in the arena. You might have a different room that's small and it has a short reverb. If we can simulate these reverbs using DSP on a sound card or on the CPU, then we can get more realistic 3D audio. The other thing that's an interesting acoustic effect that we can look at is what happens when sound tries to travel through things. So if somebody's talking to you from another room or from behind a pillar, you know that the sound becomes muffled. It becomes quieter, but you also lose some high-frequency sound. It's a bit like the EQ on your stereo system. You turn down the EQ at the high level, and the sound becomes more dull. So this kind of thing we can also recreate using DSP, using sound filters. So we can do all this stuff to the 3D sound to make the soundtrack more lifelike. I haven't given you any demos so far. The guys at Assembly have rigged us up with a nice 5.1 system, and I haven't even used it yet. I feel really bad about that. I'm going to give you a demo right now. It's a classic title, one that I played a lot too much probably, Unreal Tournament. Okay, let me find the file that I want to run. Okay, I want you to listen out for the effects that I've described. So you can hear 3D audio. You can hear reverb in the different rooms. You'll hear some reverb going on. And you're also going to hear some filtering. You're going to hear filtering when the player dives underwater. All the sounds get filtered and muffled. And later on, towards the end of the little movie, you'll see some scenarios where sound is coming from a different room or from behind a pillar, and the sound gets muffled and changed as well, so that you can identify that the other player that's attacking you is located in a different room. So here we go. Everything becomes dull and distorted slightly now because we're underwater. So there we go. That's a nice little demo. That's some pretty old stuff. I've also got some demos now to show you some newer games. People are using these effects even more creatively now. So first, I want to look at Battlefield. If you're playing Battlefield, if there's a big explosion that happens nearby you, somebody shoots a tank or drops a bomb next to you, you kind of go a bit deaf, right? As you would in real life. So in Battlefield, the programmers used these filters in order to do this kind of effect. So where is the correct thing? Here we go. So it's just a nice little effect, quite subtle, but all the high frequencies are rolled off the sound there. And there's one more demo that I want to give you from a recent game that I was raving about earlier, which is Prey. Here we go, low-pass filtering. So here, if you've played Prey, you'll know that there's this combat mode where you can have like this out-of-body experience. And in this mode, the graphics, I think, are modified, probably using some kind of graphical shaders. I'm no graphics expert. But you'll know that the sound is also modified using an effect and using these filters to signify that you're actually out of your body.
This really cannot be good.
Yeah, so now we've gone out of our body and everything's changed. So that's a nice little example of something else that we can do with filtering and with audio effects. I don't know if many of you guys came to the talk a little bit earlier by a guy called Nick Rook from Sony, and he was talking about procedural art. This is a kind of similar concept here. So what we're doing is we're taking one load of audio assets and we're reusing them. We're using DSP, we're using processing to change them on the fly so that we don't have to record samples for when I'm underwater, samples for when I'm in a big room, samples for when I'm in a small room. We just use one set of assets and we use DSP to make full use of those assets, which I guess is something that's kind of relevant for demo scene programming as well. Okay, let's get back to the slides. So we've gone through this stuff. Let's again put this into context, and let's talk about signal flow. Let's talk about the algorithms that we need to implement to do this kind of stuff. So that's the signal flow that I showed you before for basic 3D audio. We're going to add some components. We add a filter to do these filtering effects between the gain and the panning. And we need to add a reverb effect as well. So we have a reverb unit in our audio renderer. And then we have the ability here, we have to add some little blocks in to send sound to the reverb, and also to allow the developer to filter sound on the way to the reverb. So you can filter the basic sound, the 3D sound, and you can also filter the reverb sound. And we connect them up like that. Now, today it's not enough just to have one reverb. Modern environmental audio titles, modern environmental audio renderers have multiple reverbs. So we put in another slot, and another send, and another one. In fact, on Xfy we have 4, but I run out of room on the slide. But don't forget also we have these 128 or however many sounds. So you can see there's a lot of processing going on there. And it's not just on one sound, it's on multiple sounds. So this stuff's quite expensive on the CPU if you're doing it in software. Okay, let's skip ahead. I have another demo, which is from a game from last year. I don't know how popular this was out in the Nordic region, but it was a pretty good game, and a lot of people in the UK liked it. Colin McRae Rally. So this is an example. People sometimes say, hey, well, this environmental audio stuff is great for Quake, it's great for 3D shooters, but what about other kind of games? So in McRae Rally, they used multiple reverb processors. And what they did is they shot a virtual ray, out of the side of the car to see what it hit. If there's a wall nearby, if you're driving in your car, you have the window open or you have a soft top, you can hear some sound reflecting off a wall when you drive past a wall, and you can hear that on either side. So they used 2 reverb processors, one for the left, one for the right, and they simulated this idea of sound reflections. So I'm just going to play the movie, and it's a kind of a subtle effect. It sounds really good on headphones. I don't know how it's going to sound on here. We'll have a listen.
5, 4, 3, 2, 1, go. Into long 3 left, 50. 2 right tightens. Into long 5 left, tightens to 2. Into 4 left.
You can hear some stuff on your left there.
Into 6 right over crest, 30, long 2 right into tunnel. 30, long 3 left, tightens. Into long 6 left. 32 right. Into long 3 left, tightens to 2. Into long 5.
Okay, that's probably enough of that. Let's go back to those slides. Okay, that's enough about processing and stuff. Let's look at the tool layer. Yeah, as I said at the beginning, I'm going to tell you about the APIs to use, the best APIs to use, which features they support, which platforms they support, where you can get hold of them. I'm figuring that some people here, a lot of people here came to the talk by Remedy earlier, so people may be interested to get into the game industry. Maybe you want to work as an audio programmer, so maybe we can give you some tips now, which tools you can download, you can learn, and then you could impress your interviewer by talking about this kind of stuff. What I want to do first, though, is to distinguish between the low-level APIs and the tool layer. So an API like Direct Sound or OpenAL just lets you control the sound renderer. So you can play a sound on a channel, you could set a position, you could set an effect. This is all quite low-level stuff. You can't just make a call and get a compressed sound file to play back and stream with just one call. That's just not possible. That's something that should be done by the tool layer. So we're distinguishing here between the low-level functionality, playing a sound, positioning a sound, and the high-level functionality, which is creating complex sounds and playing with compression and stuff like that. So in a good tool layer, we probably have 2 main tasks. We have asset management. So that's dealing with sample compression, dealing with decompression, so we can make a file, we can put it in an OGG format or an MP3 format so that we can save space on our disk, and we can decompress it at runtime or when it's loaded. Asset management should deal with sound loading. Things like Direct Sound and OpenAL, there's no call to load a sound. That's part of the tool layer. And setting up 3D properties for sounds. If I want to say this sound has a sound range of 10 meters. I can hear it when I'm 10 meters away. This sound, I can hear it when I'm 100 meters away. Okay, you can make those settings using your low-level audio renderer, but for the audio designer to actually attach a setting to a sound, you need to do that in the tool layer. There's another important factor that you need to do in your tool layer. You need to be able to do composition, sound design. So environmental audio I was talking about, you need to be able to say, this reverb is in this room. So we can assign environmental effects to different rooms in the game. We also need to create interesting audio effects. So these days, just playing back one sample is not enough for a realistic game. You get bored, you hear it over and over again. So we need to be able to create variety. We need to be able to create interesting textures and ambiences that don't repeat and that come out in surround sound, in 3D sound. And we want to be able to create complex scripted sound. So I've got some little demos coming up. For game developers, really the goal here is to decouple the audio programmer from the audio designer. So what do I mean by that? This isn't the idea that you can increase your productivity and your efficiency if the audio designer doesn't have to go and talk to the programmer when they want to make a change to a sound in the game. So they can do it with a tool, and the game doesn't have to be recompiled. This has been something that the game industry has always been talking about, this kind of idea of increasing productivity by decoupling the programmer and the designer. And so you'll see that there's some tools out there that allow you to do that. They haven't been universally adopted yet for various reasons, but they're out there. Okay, APIs and tool choices. As a developer, a lot of you guys are developers, I'm sure, you have a number of choices open to you when you spec up your audio engine. If you're really brave, you can do what they call rolling your own audio engine. So I said that only for the hardcore. That's pretty tough. So all those algorithms that I described to you, sample rate conversion, virtualization, 3D stuff, reverb, filters, you can write them for yourself on your host, on your platform, on PC or whatever. But you've got to be pretty smart to do that. There's a number of games that have shipped using completely their own audio technology. I think originally Doom 3 just shipped with their own software renderer. There was also a game a while back that I don't know how many people here will remember, Evil Genius. That shipped with a very, very sophisticated audio engine that was completely written by the developers there. So there's been various varying degrees of success in doing this stuff. It can add a lot of time to the development process. I think probably most developers take this middle ground here. So here we're talking about using an established low-level rendering layer, something like DirectSound or OpenAL, which work on PC. Xbox 360, there was a guy here this morning from Microsoft talking about XNA. So one part of DirectX and XNA is the X audio system, which works on PC and 360. On PlayStation 3, of course, there's developer tools. There's libraries already written for you by Sony if you're a PS3 developer that give you this basic level of functionality. On PS3, it's called Multistream. We'll look at that in a minute. So then you could write your own abstract tool layer. All the complex stuff, you can write that on top. So you take the basic API and you write the cool stuff on top. Then if you don't want to do any of that, there's also solutions out there for you. So again, the bottom here we have Exact from Microsoft. So that's part of Microsoft's XNA program. It's a whole audio tool and abstract high-level API that works on PC and 360. At my company at Creative, we've developed something similar, which we call Isact. I'll show you a little bit about that later on. Again, that works on PC and Xbox 360. It's a complete solution that does everything for you, pretty much. And there's a couple of commercial middleware products available that we'll look at briefly, Fmod and Moyle Sound System. Okay. We're going to start with DirectSound 3D. Probably something that most people are familiar with. I'm not going to go into this in full detail, but it's a low-level rendering API for Microsoft platforms for PC and 360. There's the tool layer that I told you about, Exact, which has a load of cool features, compression, decompression. You can do runtime mixing, so you can adjust. You can be playing your game. The audio designer can connect on another PC and adjust sounds to hear what they sound like. All this stuff is part of the DirectX 9 SDK. So you guys, you've probably already got DirectX, I guess, but you can go down there, you can pick it up, you can pick up Exact, you can play with it, and you can become a PC and Xbox 360 audio programmer. Easy peasy. Something that's close to my heart as somebody who works at Creative is OpenAL, because OpenAL is Creative's rendering interface of choice. So there's a lot of different implementations out there for a lot of different platforms. So with all of our high-end sound cards like Audigy and X-Fi, we ship a PC hardware driver that directly responds to OpenAL calls. The same goes for some NVIDIA chipsets as well that do hardware audio. I think some early NVIDIA Enforce motherboards had hardware audio, and that had an OpenAL interface as well. All developers always say, well, hang about, it's great if it works on Creative stuff and it works on NVIDIA stuff, but what about everything else? So there's also a PC software renderer, a renderer that works on a CPU that can work everywhere. So effectively, OpenAL works on any PC. You can see also we have implementations. Apple have done an implementation for OS X. I saw some guys in Linux t-shirts earlier. There's a Linux implementation, of course, because it's an open standard. And then Creative, there he is, he's laughing. Creative have an Xbox 360 version that we give out to our development partners. That's kind of a private thing, but it's out there. OpenAL, the whole thing is driven by Creative. It's also driven by the community because it's an open standard. So if you go to openal.org, if you want to find out a little bit more, there's FAQs there, and there's some very popular mailing lists. So if you've got in-depth questions about OpenAL, you can just write on a mailing list, and all the experts will respond. If you want to pick up the OpenAL SDK, Creative have just released a brand new SDK for PC. So you can pick it up off our developer website. It's absolutely free. You can just go there and grab it. I'll talk quickly about some titles that use OpenAL. The Unreal Engine, those guys at Epic are kind of involved in OpenAL. The audio programmer there really likes it, so he's part of this group driving OpenAL. So everything from Unreal Tournament, I think from 2003, the Unreal Engine has used OpenAL. So that goes for licensees as well, so other games written on Unreal Engine use OpenAL. The Doom 3 engine has got OpenAL supported now for hardware support. Battlefield 2 and 2142. I want to do a very quick movie here of 2142 because we've got a bit of a theme for that game going through this presentation. We're giving away the downloads for the beta. I've talked about it as an important title with a lot of support. So unfortunately, the only movie that I could get hold of, it has some music over the audio track, so you can't quite hear the audio in its full glory, but I'll play some of this and it'll give you some idea for what they're doing. Battlefield 2142 from EA. I'm going to fade that out there because we've got a few other things, bits and bobs to go through, so let's get back to the slides. Okay, one other thing about OpenAL, we talked about this difference between basic 3D audio and environmental audio. So the basic OpenAL API just does 3D audio, and then fancy stuff is added in with extensions. So there's extensions for doing this environmental audio stuff, reverbs and stuff, called the OpenAL Effects extension, great name. There's an extension for playing back multi-channel audio, so if you have some music that you wrote in 5.1 or something, or you create a little movie and you need 5.1, then you can play that back with OpenAL with the multi-channel extensions. There's extensions for getting input, so if you need to grab input from the microphone for your game or for your demo or whatever, then you can record and stuff. Okay, that's the extensions. Let's talk about PS3 a little bit. I know that, why do we talk about PS3? Because we can't get hold of PS3 dev kits as programmers who are not working at game studios. But there's some interesting stuff here. I've got some buddies at Sony in London, and they said they were happy for me to mention a little bit about the audio APIs that are available for their new platform for PS3. They develop and maintain an API which they call Multistream. And it's a developer tool that they give for free to their partners in Europe. So remember here that PS3 is a multi-core system. It's just a software system, so it doesn't have a fixed audio pipeline like one of our sound cards does. It has multiple CPUs. It's got 6 CPUs, I think. So you've got a lot of flexibility there. It's got a very, very flexible routing and effects system. It can play back standard PCM wave, it can play back ADPCM compressed data, it can play back Sony's A-Track compressed system. It's got this whole great list of effects that you can do, including these reverbs for environmental audio and EQs and filters and stuff. It is only available to Sony's registered developers. However, the 3D positioning aspect of Multistream follows OpenAL, and in fact the calls for 3D positioning of sounds are very, very similar to OpenAL. So if you knew OpenAL and you were talking to a developer who was using Multistream, then you would be able to quite honestly say that you knew how to use the 3D components. So it's kind of handy to know that. And this ends with a little quote from the audio manager at Sony, and he says that next generation audio is more than just more audio channels. So what he's saying there is it's not just about being able to mix 256 or 512 audio channels. He's talking about using DSP here, like I was saying before, creating one set of assets and then using processing on the fly to change those assets. We'll whiz through this because we've got about 10 minutes, 5 minutes, so we'll go quickly. Fmod is another middleware solution. Fmod is interesting basically because you are able to get hold of a free copy of Fmod. You don't have to pay for it. In fact, a quote there from Fmod's site, many people use it for free until their commercial product is about to be published. This is a great way to evaluate Fmod, see if it suits your needs. So you can get hold of that stuff for free, and you can use their API. It's quite popular. It's been used in a few games in Europe recently. Miles Sound System is another middleware system. It's from a US developer called Rad Game Tools. It's quite PC-oriented, a lot of US titles on PC use Miles. You can look at it as the URL. Isact is Creative's tool that I told you about, works on top of OpenAL. Unfortunately, we haven't actually made it available publicly yet. We're trying to figure out a way to do that. I think it would be great if people could get hold of Isact and use it on PC and create stuff. Something you can do is you can pick up a patch that we made for Unreal Tournament 2004 using Isact. You can download that patch from soundblaster.com so you can see kind of what it's capable of. I've got a couple of quick demos, very short movies here that show you some stuff that we've been able to do with Isact. So firstly with the music, Isact has got a really complicated and really funky scripting system so that you can do interactive music. So you can, if you play the game, you get some music tracks you can choose. They're just basically long stereo files. They sound great, they're fantastic, but they don't change as the game changes. If you get killed, you just still get the same music playing on and on. Whereas in Isact, we've been able to create a 3D soundtrack in 5.1 that actually responds to the way that you're playing the game. The easiest way is just to demo it. So here's a little movie. I turned it down, didn't I? Let's stop that and play it again. Shouldn't mess with the audio level. There we go. So I'm going to make a kill, and I'm going to get a little... you got a nice little triumphant little riff. I took a hit there, and I got killed, and the music just ends nicely. So you can see how that music is reactive to what's going on in the game. The other thing that we did with Isaac and Unreal Tournament is that we changed the weapon sounds. We made some nice 3D weapon sounds. We're a little bit short on time, so I'll move it towards the end, because the best one's the rocket launcher. And the lightning gun there. So that's some pretty cool stuff that we put together. Back to the slides. Okay, we want to talk about the future very, very quickly. So what's going on now? Vista. Vista's a huge thing for anybody that's concerned with PCs. The new operating system from Microsoft is going to be very cool. It's going to be very funky. You're going to be able to do loads of cool stuff with it. So a core focus for creative is obviously getting some drivers and some products that work really, really well with Vista. One thing to note about Vista, and this is public information now from Microsoft, is that Direct Sound 3D that I was talking about under Vista is still there, but we can't write hardware drivers to do hardware 3D using Direct Sound 3D. They were not able to implement that in the first release of Vista. So the only way to get hardware audio support, so to get hardware mixing, hardware reverb, all these cool stuff on our sound cards, is to use OpenAL. So clearly that means that we're going to be putting a lot of focus into OpenAL, into developing it. The other thing that we talked about, and coming on from the Sony thing, is about more DSP. So this PS3 platform is a software platform. It's really, really flexible. You can do loads of cool stuff with DSP. You can make your own effects and stuff. So that's going to be something that game developers are really going to start looking into in the future. With a fixed audio pipeline on PC, we can't quite be that flexible. Our processor is configurable, so we can reconfigure it with new drivers. So we're going to try and add some cool effects to give developers the ability to do a lot of what they're going to be doing on console. So I'll put that in the context of this diagram I showed you earlier. So here's our signal flow. There's some areas where we can do research to improve stuff. First of all, we can do what's called insert effects, or per source effects. So there, if I want to put a distortion sound on just one sound in the game and have that move around in 3D with the sound, I can use an insert effect for that. So that's some aspect that we're really researching at the moment. New effect types. Reverb's really, really useful, but it would be cool to have some other new effects. Developers are talking about things like they want to record vocals for their game, like dialogue, and they want to be able to change that dialogue to make the player sound like he's old or young or evil or good. So we could do that. We could develop new effect types to do stuff like that. That's another area where we're doing some research right now. New filter types, of course. For environmental audio, we just use these low-pass filters where we make the sound duller. But we could create new filter types, EQs, that really let you play around with the tone of the sound. So it looks like I'm pretty much out of time. I've used all the time we've got. We've probably got 5 minutes for questions, but I think we're going to stop there. And I will answer some questions if you have any, or you can come and check stuff out and talk to me maybe at the creative stand a bit later if you want to do that. Okay, we have a question here.
When you bought the Unreal 3D, they had a very good 3D sound system way behind, way ahead of your technology. What happened to it? Did you absorb it and bury it, or what?
So the question is about Oriole, the company Oriole that used to make 3D audio technology as well. The creative bought out probably a year after I joined the company. Well, I was talking about this portfolio of binaural recordings that we have. For giving two-speaker virtualization. That's something where we found that Oriole were very strong. They had some great IP and some really realistic virtualization algorithms for giving this 3D experience on two-speaker systems. So that technology, yeah, absolutely. We've used that. We've taken advantage of that, and we've used those algorithms to develop our 3D for X-Fi. So yeah, we've used that IP definitely. Are there any other questions? Sorry, are there any?
New products that Creative Labs will be publishing
Some new creative products. That's a tough call. I don't think I could say anything because I'm not really like a business guy that deals with sales and marketing and stuff. One thing to look out for would be that we tend to refresh sound card products before Christmas, so you would probably want to look around then. Maybe we'll have some new products then. And of course Vista, we'll be looking at some interesting products for Vista when that's released. But that's all I can say really. New chips in the sound cards. Well, the X-Fi chip, the 20K chip, that's been in development a long time. It's a very, very powerful chip. We're going to continue to develop it, but we're not going to bring out another chip that's as much of a leap ahead as X-Fi was, I think, for probably quite a while. What we can do is we can increase the power through driver releases and also through making sort of enhancements to the chip itself, but I don't think we're going to be introducing a new architecture for quite a while, I would say. Hi.
What happened to the Audi 3?
What happened to the?
Audi 3.
The Audigy 3. Oh, right, I got you, yeah, because there's Audigy 1, Audigy 2, and Audigy 4. Well, I guess Audigy 2 ZS is probably Audigy 3. Maybe that's a good answer that marketing would give you. Maybe 4 was a nicer number than 3, I don't know. That's a funny question. Any more? Yes, please.
Third-party developers have been making drivers especially for the Audio series because many people have been disappointed by your driver support. So what can you say about that, and are you improving the driver support?
Yeah, so you're talking about things like the KX project. Yeah, there have been other drivers for Audigy. X-Fi drivers, in my experience so far, have been pretty stable. People sometimes have problems if they don't uninstall their old system properly before they install the new drivers. But I think you'll find that the X-Fi drivers are pretty stable. I think we've taken on board those comments. I think we've put a lot of focus also on improving the drivers on our low-end products, because we used to have a lot of low-end products which had software drivers, and I think maybe we've had some issues with those, and we've spent a lot of time working on those as well. So yeah, Creative definitely listens when people criticize any products that we have, and we do try to put a lot of resource into drivers. I think we're doing that pretty well. I think we're doing a pretty good job of that, but we're always listening to people's input. There's a question right at the back there.
Are you planning to include physics in sound cards?
So the question is, are we planning to do physics in sound cards? And the answer is no. No, I don't think we are. I think Aegea and Havoc and those guys have all got some pretty nice ideas, but I think we're going to stick to audio. Hi.
When will come out X-Fi PCI Express card?
A PCI Express card based on X-Fi, the answer is I don't know. You'd have to ask one of our marketing guys. I couldn't say. I couldn't answer that question, I'm afraid. Okay, I guess it's time for the next presenter in a minute, so I better scoot off the stage. But thanks very much for listening, and thanks for coming along. And enjoy Battlefield 2142 when you pick it up.